Pre-statistics. Solving radical equations, part 2. Lesson objectives: solve a radical equation in one variable. Compute the x-intercepts of square root functions. Example 4. Solve x equals the square root of 15 minus 2x. Solution. Our first step is to get rid of the square root, so we have to square both sides of the equation. The square and the square root cancel, so we're left with x squared equals 15 minus 2x. Now this is a quadratic equation. Moving everything over to one side of the equal sign, we can use the quadratic formula. In this case, a is 1, b is 2, and c is a negative 15. So negative b plus or minus b squared minus 4ac divided by 2a. We work inside the square root first. 2 squared is 4. 4 times 1 times a negative 15 is a negative 60. 4 minus negative 60 becomes a positive 64. We now take the square root of 64, which is 8. So we have negative 2 plus 8 divided by 2 and negative 2 minus 8 divided by 2. And our two solutions become x equals 3 and x equals negative 5. Now we need to check both negative 5 and 3 to see if they satisfy the equation. For x equals 3, we have 3 equals the square root of 15 minus 2 times 3. We multiply first. 15 minus 9 becomes 9, and the square root of 9 is 3. It checks. For x equals negative 5, we have negative 5 equals the square root of 15 minus 2 times negative 5. Now right here is already see a problem. Square root of a number can't equal a negative number. So even if you work it out, you're going to get negative 5 equals 5, and that's not correct. So the only solution we have is x equals 3. Process to solve a square root equation in one variable. Number 1, we isolate the square root term on one side of the equation. We square both sides. Then we solve the equation. And finally, we want to check that each proposed solution satisfies the original equation. Example 5. Use the graph to solve the square root of x plus 8 equals x squared minus 3x minus 4. So we're going to solve this graphically, not algebraically. Solution. We type in the left-hand side of the equation y1 and the right-hand side, the quadratic equation, in y2. We hit graph. There's 2 points of intersection. So using the intersection feature, the first point is a negative 1.47 rounded off, and the second one is 4.63 rounded off. Lesson objective. Our last example, example 6. Find the x-intercepts of the graph f of x equals the square root of 3x minus 4 minus the square root of x plus 2. Solution. To find the x-intercepts, we let f of x be 0 and we solve for x. We will add square root of x plus 2 to both sides to isolate the square root. Next, we square both sides. The squaring and the square root cancel, and we're left with 3x minus 4 equals x plus 2. Subtracting x to both sides and adding 4 to both sides, we have 2x equals 6. Divide by 2 and x is equal to 3. To check it, we put 3 back into the original equation. 3 times 3 is 9, minus 4 is square root of 5, minus square root of 3 plus 2, which is square root of 5. Square root of 5 minus square root of 5 is 0. This is a true statement, therefore 3 is a solution. To verify this using the graphing calculator, put the equation in y1 and then verify that the x-intercept is at 3, and it is. Thanks for watching.